We'll start with the weird and work our way up to the most diabolically unsettling anomalies ever discovered: ball lightning. The ball lightning phenomenon appears as a glowing, floating sphere of light, usually between the size of a golf ball and a beach ball, that shows up during or after thunderstorms. People who've seen it firsthand describe it floating through the air, passing through windows, and sometimes even through walls, before either fading out of existence or exploding with a loud bang. The problem is, science still has no agreed explanation for what it actually is. Researchers have proposed over 200 different theories, including plasma formations, microwave radiation trapped in a bubble of air, and even antimatter. In 2014, Chinese scientists accidentally captured ball lightning on video for the first time while recording a thunderstorm. The footage showed a glowing orb about the size of a basketball, traveling horizontally for about 10 seconds before disappearing. The spectral analysis suggested it contained silicon, iron, and calcium, which are all elements found in soil, which hints it might form when lightning strikes the ground and vaporizes minerals. But that still doesn't explain how it floats, why it passes through solid objects, or why it sometimes lasts for nearly a minute. We can't even reproduce it reliably in a lab, which makes controlled experiments basically impossible. The fact that we've had written accounts of this going back to the 1600s, and we still can't fully explain it, is honestly a bit embarrassing. The Taos Hum. In a small desert town in New Mexico called Taos, residents have reported hearing a low, steady humming sound since the early 1990s. They describe it as something like a distant diesel engine that never turns off. The strange part is that only about 2% of the town's population can hear it, and sensitive recording equipment placed inside the homes of people who reported the hum picked up absolutely nothing. Researchers from the University of New Mexico ran a thorough investigation and came up empty. There were no buried machinery, no military signals, no industrial source that matched the description. A theory for why it happens involves something called spontaneous autoacoustic emissions, which are faint sounds your own ears produce internally. In a very quiet environment, some people might become aware of these internal sounds in a way they never would in a noisy city. What makes this theory more compelling is that several people who reported the Taos Hum said they still heard it after moving away from the town entirely, which strongly suggests the sound isn't coming from the environment at all. No explanation has been officially confirmed, and the hum continues. The wow signal. On August 15, 1977, astronomer Jerry Eman was reviewing data from Ohio State University's Big Ear radio telescope when he came across a signal so unusual that he circled it on the printout and wrote "wow" next to it in red pen. The signal lasted 72 seconds, came from the direction of the constellation Sagittarius, and matched almost exactly what scientists expected an intentional transmission from an extraterrestrial source would look like. In simpler terms, they think it could have been a signal from aliens. It was a narrowband signal, meaning it was concentrated on a very specific frequency, specifically the 1420 MHz hydrogen line, which is the frequency scientists had long suggested would be the logical choice for interstellar communication. Despite dozens of follow-up attempts using far more powerful equipment, the signal has never been detected again. Various natural explanations have been proposed over the decades, including comets, interstellar hydrogen clouds, and even Earth-based interference. In 2017, one researcher suggested it came from two comets passing through the field of view. However, scientists weren't convinced. To this day, we still have no idea what it was. Dark flow. In 2008, NASA astrophysicist Alexander Kashlinsky and his team noticed something strange while studying the motion of galaxy clusters. Hundreds of clusters across the observable universe were all drifting in the same direction, toward a specific patch of sky. This wasn't supposed to happen. According to standard cosmological models, galaxy clusters should move in random directions, influenced only by local gravitational forces. But they weren't. This became known as dark flow. One of the leading hypotheses is that there could be something insanely massive just outside the edge of the observable universe that's pulling everything in its direction. However, we'll never be able to see it or study it directly. Some researchers have disputed whether dark flow is real at all, and argue that the statistical methods used to detect it were flawed. As of now, there is no consensus. The data exists, but nobody yet agrees on what it means. It either confirms something beyond our universe, or it's the result of a measurement error. Fast radio bursts. Fast radio bursts, or FRBs, are intense millisecond-long pulses of radio energy that come from deep space. The first one was discovered in 2007 by astronomer Duncan Lorimer while reviewing archived telescope data from 2001. In that tiny fraction of a second, a single FRB can release as much energy as the sun produces over several days. For years, scientists thought they were one-time events caused by cataclysmic things like collapsing neutron stars. Then in 2016, they detected a repeating one, which ruled out any explanation involving total destruction of the source. Even more confusing, a recent discovery tracked a repeating FRB to the outer edge of an ancient elliptical galaxy containing only old dead stars, where there shouldn't be any high-energy stellar activity. The source was located 130,000 light-years from the galaxy's center, farther from any galaxy's core than any other known FRB. We're still not completely confident for how or why they happen. All we know is that FRBs are real, powerful, and extremely frequent across the universe. Tabby's star. Tabby's star is a star about 1,400 light-years away that has been dimming in ways that don't match any known natural process. Most stars dim slightly and predictably when a planet passes in front of them, but Tabby's star dims by up to 22% at completely irregular intervals, and it's also been slowly fading overall for over a century, based on historical photographic records. When astronomer Tabitha Boyajian published the data in 2015, the internet immediately jumped to the alien megastructure theory, specifically the idea of a Dyson sphere, which is a hypothetical structure built around a star to harvest its energy. That's probably not it, though. The more accepted current hypothesis involves large clouds of dust and debris, possibly from a disintegrated planet or comet family, passing unevenly in front of the star. But even that hypothesis doesn't cleanly explain the gradual, century-long fading of the star. The axis of evil. When scientists mapped the cosmic microwave background, which is the faint radiation left over from the Big Bang, they expected the temperature variations across the sky to be completely random. Instead, they found a large-scale pattern in those fluctuations that seems oddly aligned with the plane of our solar system and even the direction Earth moves through space. This alignment was nicknamed the Axis of Evil by cosmologist Shwoma Geho because it directly contradicts the standard model of cosmology, which assumes the universe should look statistically the same in all directions. The odds of this happening by chance are estimated at less than 0.1%. Some researchers think it's just a data problem, like a measurement error. Others argue it's pointing to something genuinely wrong with our current understanding of the early universe, possibly indicating that the Big Bang itself was not perfectly uniform. The Great Attractor. Somewhere around 250 million light-years away from us, there is something pulling our galaxy, along with thousands of other galaxies toward it at about 2.2 million kilometers per hour. Scientists call this the Great Attractor, and it is about 300 million light-years wide. The big problem with studying it is that it sits almost exactly behind the densest part of the Milky Way's own disk, meaning all the dust and stars in our galaxy block our view of it almost entirely. What we do know is that the gravitational pull is far greater than the visible matter in that region can account for. Early estimates suggested the mass of the Great Attractor to be equivalent to tens of thousands of galaxies. Later surveys using X-ray telescopes that can penetrate the galactic dust revealed a massive supercluster of galaxies called the Norma cluster at its center, but even that doesn't fully explain the scale of the attraction. There may be a larger structure behind it called the Shapley supercluster, and some researchers believe the Great Attractor may be a part of it. If you like this video, subscribe for similar ones. Thanks for watching!